Hello, welcome to Chapter 7, Ratios and Proportions. First, I want you to make sure to write down these 3 steps, because when we have a word problem and we're solving ratios, proportions, which we'll talk about, this is what I want you to do. Just a little review here. When talking about proportion, you will hear me say proportion a lot, or else you will hear me say fraction equal fraction. So if I had 5/8 is equal to x over 20, fraction equal fraction, that's a proportion. And how we typically are going to solve a fraction equal fraction proportion is we're going to cross multiply. And this is just reviewing how to cross multiply top times the bottom, top times the bottom, right there. Again, just a little reviewing. So if I have fraction equal fraction, I'm going to start off with a D. These two get multiplied together. You want to be very careful whenever you have an equation in the denominator or numerator, because the number has to be multiplied by that whole thing. So 3 times 4n plus 1 is going to be equal to 2n times 7. So this becomes 12n plus 3 is equal to 14n. I'm going to subtract 12n from both sides, and I get 3 is equal to 2n. And then my final answer would be 3/2 is equal to n. Right now I want you to pause the video. Yes, pause the video and see if you can do A, B, and C by yourself. You should have gotten that A was equal to 24 over 5, B is equal to 40 over 3, and C is equal to 2. Now, if you put your answer in decimal format, I always want you to round to the nearest hundredth. That is 2 decimal spots. A few properties of proportions of fractions is, first, whenever I have my beginning fraction, A and C should always be paired somehow, and B and A should always be paired somehow. So you can rewrite proportions so that is true. So this is going to be equal to AC BA, because they're in the same spot, so it's just flip-flopping the top and bottom. Or, again, AC and AB are partners, so AC can be on the same fraction as long as AB are across from each other. Or, again, AC and AB, if I add B to the which is on the bottom of my fraction, to the top, then I also want to make sure that I add D to the top of my fraction. So all of these are equivalent to each other. So how are we going to use those proportion properties to help us? Again, this is my original proportion. So if I have x is equal to y, or x over y, x and y are partners. X should also be partners with 6. So this should be 6 over 7. How did I know it was 7? Because 6 has to be partners with 7. If 6 is over x, what are my 2 numbers? Well, 6 has to be partners with 7, and x has to be partners with y, so it'd be 7 over y. Now this is with the adding one. If I look at my original problem here, erase some of this, I have y plus 7. So in my original problem, I did y plus the bottom, so I have to make sure to do x plus 6, because it would be x plus the bottom, and you still have the bottom of the fraction on bottom. That's saying bottom a lot of times. Now, done with the review, we're going to actually start talking about ratios and what ratios are and word problems with ratios. So back to those 3 basic steps I had at the beginning of the video. Ratios is just comparing 2 numbers, or you can have it as a fraction with a colon, or comparing A to B. B can never be equal to 0 when I'm talking about ratios. Since we're done reviewing, we're going to actually talk about the ratios. So a model is made of a car. The car is 9 feet long. I'm going to make sure to underline that because I'm probably going to have to use that with something. And the model is 6 inches long. So what is the ratio of the length of car to the length of the model? This is key here. It's telling me that the length of the car should be first. Now again, you can represent this in multiple different ways. I have 9 feet over 6 inches, or I could rewrite this as 9 feet and then colon 6 inches, or I could write it as 9 feet to 6 inches. However, with all of these three cases, you should always simplify your ratio. So when I look at 9 and 6, both of those numbers can be divisible by 3. So I could either have 3 feet over 2 inches, or 9 feet colon 2 inches, or 3 feet. 3 feet to 2 inches. All of those are the same. I want you to pause the video and see if you can write up your own ratio for problem B. So you should have gotten this 60 over 1,250. How did I know to put 60 on top? Because it's asking you to put the model to the length of the actual. So model should go on top. Now I have to simplify this. Now whenever you have a number over number and there's a 0 in both, I can just cross out those zeros. 6 and 125 are in simplest format. So my final answer would be 6 inches to 125 feet. Again, you could have written as with a colon or with 2 in the middle. Here's another word problem. Members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan on buying 120 pots of flowers, and the ratio that they want is 2 to every 3. So how many pots of each type of flower should they buy? So I can write this up as an equation. Things I know. I know that the ratio is 2 to 3. That means for every 2 pots of tulips, there's going to be 3 pots of daffodils. So that's a total of 5 pots for the ratio, because I have to add my ratios together. So this is my total. So your total is always going to be equal to your total of what you're talking about. In this case, I'm talking about 120. So I'm going to have 5x is equal to 120, because this is the total number of pots that I need, and this is the total number of pots I am buying. So if I divide each side by 5, it gets that x is going to be equal to 24. So what this number represents is my multiplier. This is not my final answer. Again, I have to use my ratio of 2 over 3. But since I know my multiplier, I'm going to use my multiplier to figure out what my total will be. On both ends, I'm going to multiply the top and bottom by 24. So when I multiply the top by 24, top was talking about tulips, I'm going to have a total of 48 pots of tulips, and I'm going to have a total of 72 pots of daffodils. And that's how I figure out what my multiplier is, to help me figure out the total. This second problem, I have to know what complementary is. 2 complementary angles are in the ratio of this. Complementary. That means that 2 angles add up to 90 degrees. So that means these are my 2 angles, 1 and 3. So I'm going to have 1x plus 3x is going to be equal to 90. That's going to help me figure out what my multiplier is, so I can plug it back in. So that's a total of 4x is equal to 90. And when I solve that, I get x is equal to 22.5. Again, this is my multiplier. This is what I use to help me figure out what my total is. So I don't want to figure out what both angles are. So one angle, smaller angle, the ratio of 1 is just going to be 22.5 degrees. Because 22.5 times 1 is 22.5. My other angle is going to be 3 times my multiplier. So that's going to be 67.5 degrees. And these are my 2 angle measurements with using my multiplier for my ratio. In my last 2 examples, what if I'm talking about something with more ratios? Well, in this case, it's saying the side lengths of a triangle are in the ratio of 3, 5, and 6. So again, I have to figure out what did I simplify this ratio by. That's what the multiplier is. I'm looking for, or I have the perimeter is 98 inches. What is the length of the longest side? So I know that my 3 side lengths, So I have 3x plus 5x plus 6x is equal to 98. How do I get this? This is my total, and you always have to use your ratio in the problem with your multiplier to set up your equation. So in this case, I'm going to have 14x is equal to 98. I get that x is equal to 7. Now here's my multiplier. So now I want to figure out what's my longest side. Now you could plug it into all three ratios if you wish to. However, the number that has the highest ratio is going to give you your highest or largest side. So I'm just going to actually do 6 times 7 because this was my highest ratio. That's going to give me my longest side. And that's going to give me 42 inches. My units here was in inches. The angles of a triangle are this. Angles. What is the measure of the smallest angle? So when I think about a triangle and angles, I know that the total is equal to 180. So I'm going to write my ratio with my multiplier. 2x plus 5x is equal to 180. Because this is my total angles added together to equal my total angles. So this is going to give me 10x is equal to 180. And so x will be equal to 18. And it's asking what's the smallest angle. So just like the last problem, my smallest ratio will give me my smallest angle. So I'm going to have 2 times 18 here, which would give me 46 degrees. And that would be my smallest angle in this triangle. Make sure to fill out the Google form and take notes, and go back to take notes if you didn't. And I'll see you later.